Hello everyone and welcome to day 5 of Unit 5. We are looking more at quadratics, specifically with quadratics that do not have actual real roots. We talked about this the other day with discriminant. When the discriminant of b squared minus 4ac is less than 0, meaning what's underneath the square root is negative, we know that the quadratic has no real roots. We talked about this idea that it has two complex roots, where it never crosses the x-axis. When we talk about this, we said they're imaginary roots, or complex roots. There's always two of them. One positive, one minus. They're called conjugates of each other. When this happens, and we're going to talk about the history of this in class, so for this video we're going to talk only about the actual way to solve them. The key to this solving is the fact of knowing that the square root of -1 equals I. When that is the imaginary portion of it. So just a quick overview here. If I have the square root of -4, I hope we can agree on the fact that the square root of -4 is the same thing as saying the square root of 4 and the square root of -1. When we have the square root of 4, we know the square root of 4 is just 2. And we know that the square root of -1 is I, and so we have square root of -4 is equal to 2I. And that's the imaginary portion of it. The square root of -1 creates the imaginary portion of I. And this is going to help us solve the complex roots when we're given quadratic equations that create complex roots or imaginary roots. So, first one, nothing changes. Please know that. Nothing changes with how to solve these. For A, x equals -b, that's going to give us 10 plus or minus the square root of b squared, -10 squared, minus 4 times a, which is 1, times c, which is 29. All divided by 2a, which is 2 times 1. Nothing new here. You get x equals 10 plus or minus the square root of 100 minus 116, all divided by 2. We continue. 10 plus or minus the square root of -16, all divided by 2. Now this is where we see a negative number, and in the past we've just said no real roots. This is where we have to now change this. This is the square root of 16 and the square root of -1. So we're going to get x equals 10 plus or minus. The square root of 16 is 4. The square root of -1 is I. Divided by 2, and exactly what we did in the other video. You're going to do 10 divided by 2, and you're going to do 4i divided by 2. You cannot just do one or the other, you have to do both of them. So you're going to get 5 plus or minus 2i. And your two roots here, because we always said there was 2, is 5 plus 2i and 5 minus 2i. Just to go back here, so you know this, you could have written it as 10 divided by 2 plus or minus 4i divided by 2. And that'll show you how you can cancel both separately. So we'll move on to number 2 here, or B. For B, you'll notice that there's a little bit of difference here, that we don't have a single x term, a term with a single x. Not an x squared, but a single x. In this case, there are two ways to solve it. You can do quadratic formula, there's nothing wrong with that. But you can also solve it just by moving the 16 over, dividing by 4, and then square rooting both sides. And notice when you square root, we did this with completing the square, you need plus or minus. Remember that the square root of 4 can be rewritten as square root of 4, square root of -1. Did that right, actually, next to that, right here. You get plus or minus 2i. Now we usually write complex roots with the real number portion first and the imaginary portion second. So we're going to do 0 plus or minus 2i. Done. And that's it. You could have used quadratic formula. There's nothing wrong with that. Just know that you could have done it that way. Let's move on to C. C, you get x squared minus 4x plus 13 equals 0. So we'll get x equals negative b, which is 4, plus or minus square root of b squared, negative 4 squared, minus 4 times a, which is 1, times c, which is 13, all over 2 times 1. 16 minus 52, all divided by 2. So we'll get x equals 4 plus or minus the square root of negative 36 over 2. Again, square root of negative 36 can be rewritten as square root of 36, square root of negative 1. We know that to be 4 plus or minus 6i divided by 2. And we can rewrite that as 4 divided by 2, which is 2, plus or minus 6 divided by 2, which is 3i. And there's your answer. X equals 2 plus or minus 3i. What I would like you guys to do is pause the video and attempt to do letter D, which is 3x squared minus 18x plus 30 equals 0. So pause it, try that one, and I'll come back with my work and the answer, and hopefully we got the same thing. And here's the answer to D. Take a minute, look at it, make sure you got it correct, and we'll move on to the next page. The following page, what I would like you guys to do right now is summarize the math A, B, and C. That's it. We'll go over everything else, but please have summarized the math A, B, and C completed and ready to go in class for day 5. Other than that, enjoy your day, and I will see you guys in class. Bye.